Everyone, and welcome to the Retro channel. Today we're going to be checking out a Commodore 64C that is in need of repair. So without further ado, let's jump straight into it. So as you can see, this is one of the later design Commodore 64s. It actually has all the information printed on the tops of the keycaps, whereas the previous ones had the functions printed on the sides, much like the 64C that I've got up there. So pretty late design. And looking around the back, we can see C64C, serial number HB41401525E. Made in Hong Kong. There is some spots here where some feet were placed on there, but it looks like it's just the actual felt that's left over, and they're not actually going to make contact with the bench anyway. Interestingly, the 2 feet are still on the bottom here, so I'm not sure why somebody added extra feet, but anyway. The warranty seal has been defeated, and there's also an odd screw over here. No idea what that's all about. That is definitely not a standard. First things first, let's just power this thing on and see what it does, if anything. Alright, so the capture device is set up and ready to go. Let's see what happens. Well, I heard a pop, so the capture device does seem to be working, but we're getting no signal. So usually you'd at least get a black screen or something, but this one appears to be putting out no signal at all. I'm just going to do a quick test with a working machine just to make sure I haven't screwed up something in the capture chain. Got the trusty old ZIF socketed 64. Let's just see if this is working. Still no signal, so maybe I'm just a numpty. There. The S-video cable wasn't plugged in properly. Right. This is working. Let's go back to the other machine and check that again. Always pays to check your capture setup. Right. Okay. Definitely no signal. We do have 5 volts, so at least the machine is partially working, but we're not getting any video output. So I think it's time to open this thing up and see what we've got on the inside. And we'll get to find out what this mystery screw is all about. It is definitely attached to something inside. Okay, so there's a bit of mess going on with this LED connector. So this is kind of a quirk with the Commodore 64Cs, because the early ones had a long board in them, so the power LED connector was actually back down here somewhere, whereas the later designs with the short board, the power LED connector is up here. So it looks like somebody just repurposed this LED connector, which would have only had a short cable, and made their own extensions there. I also noticed that we are missing a bracket for the keyboard over here, and that's where that screw is going. So it looks like somebody put their own screw in there just to sort of hold the keyboard in place on this side, because they didn't have the bracket that's supposed to sit up here. So that kind of explains that. So definitely we've got a case of a later Commodore 64C that probably came with a short board revision, and somebody has stuck their own longboard in here. So this is definitely not the original board that came in this computer. Now I've got to try and get that bloody thing out. I don't have the right size socket on hand, but we should be able to do a little bit of fiddling with some pliers to loosen up that nut. There we go. There is our flathead screw. Random. At least they put a washer on one side. That's nice. Okay. So yes, as I was saying, the power LED connector is over here, and that, yeah, somebody's just, looks like they've chopped the connector off something else, like a fan or something, and then just made their own little extension. But we can clean that up later. That's not a big issue. So we do have one of the keyboard brackets here, which, yeah, does screw into the main board there. So that holds that in place. But there are two different brackets that can go on the left-hand side. One of them obviously fits the short board, which has a screw hole approximately in this area. And one of them fits the long board, which is supposed to screw into this area. But the bracket is missing at the moment, so there's not much we can do about that. But I'm pretty sure there is 3D printed versions of both of those different brackets available online. So we'll look into that. We'll come back to that later. So the board itself is a 250407 revision, Rev B. So a very old board in a fairly modern case. Relatively speaking, of course. All right, let's plug this back in and we'll check out some voltages, see what we're getting. Might just plug the video signal in just in case we see something exciting. So it does pop when I flick the power switch on. So that tells me the SID is probably working. And well, that's kind of funny. We have very old PLA, the 82S100. So let me zoom in on that. So yes, the 82S100 is the original sort of PLA before Commodore basically made their own MOS version. Looking around the board, we've got an 83 CIA and an 89 CIA. So this is from a short board, and this is probably the original. Yeah, there's definitely a mixture of old and new ICs in here. The CPU's an old one, very mixed bag. Looks like very much a parts machine that somebody's thrown together from other machines. So we've got no video output, so the first thing we want to test, regardless, is our voltages. So an easy way to test for voltages on a Commodore 64 is just to go straight to the user port. You don't necessarily even have to open the machine up to do this. And you just want to look for the pins around these two notches. So the two pins around the notch on the right hand side should have our 5 volts DC, and the two pins around the notch on the left hand side should have about 9 volts AC, give or take 1 or 2 volts. So that's all looking good. And that also tells us that the fuse is intact, because otherwise we wouldn't see the AC voltage over this side. So it seems like the VIC2 is getting voltages. If we're not getting a video signal, then chances are there's an issue with either the VIC2, the clock generation, or the RF modulator, or pretty much something in this area of the board. So that's what we're going to focus on. And the next best thing to look at is these two voltage regulators down here. So this one over here is a 5 volt regulator, and we can just put our negative probe on just some bare metal. That'll provide a ground. And if we probe pin 2, which is actually the topmost pin, we can see that we get 5 volts there. And same on the 7812, if we probe the rightmost pin, which is also marked as pin 2, we can see 11 volts there. So Our voltage regulators are working, and these provide voltage, at least in this board revision, to the VIC2 and our SID. So the VIC2 should be getting voltage, and in fact I can feel that the can is slightly warm, so the VIC2 is warming up. So it could be a case that we're missing the clock signal, and for that we're going to have to pop open this can and take a look. There is one single crystal in the Commodore 64 that controls all the different various clocks. So the 1 megahertz or thereabouts for the CPU, and also the video signal clocks as well. So let's pop this can open and take a closer look inside. And yes, so these ones with this type of can, you can pretty much slide a screwdriver just under this part here and then just kind of lever it up. Cool. Thermal paste is there, although there's not much on the actual VIC itself. So whether or not that thermal paste was actually making good contact, I don't know. It's pretty dry though. So the VIC2 itself gets quite hot, and if there was poor contact between the VIC2 and the heatsink, it may have already cooked itself. And yeah, interestingly, this is the ceramic packaged VIC2, so it's a very old VIC2 chip in here. Let's just take a closer look at that VIC2. So it is a, by the looks of it, 6569R1 VIC from the 11th month of 83. So yes, very early VIC, and possibly why we're not seeing video output, because it may already be dead. Right, so I'll just power on the machine again and we'll just check some voltages on the VIC2 itself. So again, we'll just use a nice metal spot on the board, and pin 40 should be 5 volts, 4.98, that looks good. The other one to check is pin 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Pin 13 should have 12 volts, which it does. So VIC is definitely getting power. That's all good. What about the actual clock signal? Right, so the multimeter is saying 0 hertz on the crystal itself, which isn't a good sign. Let's just have a look on the VIC. So yeah, we should see clock frequencies on these pins over here as well, pins 21 and 22, and we see 0. So I think it's time to get the oscilloscope out and check this properly. Right, so I've just kind of wedged the oscilloscope here, but we can see the frequency counter at the bottom. So let's check again. I'm just going to hook this, let's just hook it on there and hook up to one of these pins on the crystal. And yeah, that is nothing. That's just noise. Let's check the other side. Yeah, nothing at all. So we're not seeing anything. We should see a nice sort of sine wave almost signal here, and we get absolutely nothing. So it would appear to just be a dead crystal. Let's dig in a little bit deeper. All right, so just taking a closer look around this crystal area, and I notice this capacitor here appears to be leaking. So that is not a good sign. Yeah, there is some crust around the legs. I don't know if that's the original though. That looks like it's been replaced perhaps, but either way, that should probably come out. And there is some crust around the legs of this cap as well. So something has leaked into here. And in fact, looking at this trace that goes off the crystal, it almost looks black. So I think something has definitely eaten into that. Can sort of reveal a bit of shiny copper underneath, but yeah, looking around, something has leaked and it has started to corrode at least the solder mask and potentially the traces underneath. That's not a good sign. So it's pretty rare for a crystal to just stop working. I mean, it can happen, but I definitely want to investigate some of these dubious looking traces. Yeah, it certainly doesn't look healthy in this area, so let's just scrub everything a little bit. Alright, so after a quick clean and a blow dry, I don't expect that to make any difference, but let's just check. Yeah, still no signal, so I dare say no clock signal is being generated. Is that the crystal? Is that one of the supporting ICs? That is the question. So looking at the schematics, the crystal is directly connected to pins 12 and 13 of U31, which is a 74 LS629. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's have a look at pins 12 and 13. And yeah, again, we are seeing nothing, which seems about right. That's what we saw at the crystal as well. Let's just double check, make sure this thing is receiving power. So we should see, pin is that? Pin 16 should be our VCC. We should see 5 volts there, which we do. That looks fine. So nothing looked out of place on the oscilloscope, but because there's no activity from the crystal, there's not really anything going on the board as such. But let's just double check some of these traces again. So this side of C70 should connect directly to the crystal, which it does. And the other side should connect to that pin of the 629, which it does. So yeah, everything seems to be working in terms of connections to and from the crystal. What's the possibility that this 629 has an issue? Is it going to be with the IC itself or just the connections, which, yeah, do look a little bit corroded in some spots? Let's pop the board out. Ew. There's some big chunky bodges here. They go to the video output DIN connector, so that's a bit of a worry. So this one here appears to just be going to the ground plane. It's a bit strange. The other one is going to one of the pins that sits under the RF modulator, which also pops back out here. So it's likely one of the video signals, but that wouldn't be causing our missing clock. At least it shouldn't. You can also see that there was a couple of ICs replaced over here, so there's bits of flux everywhere, and there is what could be a dead insect. Don't know where that went. The rest of the board looks pretty normal, so yeah, it's just these two that have been replaced. That looks like the color RAM and possibly one of the regular RAM chips. That's a multiplexer for the RAM, or a demultiplexer. So these two have been replaced, which are both 74 logic. Possibly they may have had the MOS versions in there, which are prone to failure. So those two have been replaced, but yeah, that wouldn't explain our missing clock signal. So looking at the underside of the board, this is our VIC2 just here, or at least the underside of it, and that is our 629 IC, and over here should be our crystal. So everything looks fine on the underside, but obviously the camera will focus. Yeah, not so great on the top side. So what I might do is just go around with a little bit of desoldering braid and just sort of clean up some of these bad solder joints and get them nice and shiny again. Yeah, there's just too much corrosion in this area, so what I'm actually going to do is pop out most of these components and just either clean them up or replace them. But yeah, I can't break through half of this stuff with all the components on the board. So let's just do another final test. I doubt the little that I managed to reflow is going to make any difference, but we'll just do a quick check, see if there's black screen or anything. Nothing at all. I'm going to remove some of these components, especially this guy and these electrolytic capacitors, and do some further cleanup here. So for the generic stuff like this 100 nanofarad ceramic capacitor, simply just going to clip it out and replace them. Same with these two electrolytics. And yeah, that's definitely some leakage there, which has destroyed some other stuff by the looks of it. So yeah, these can come out, and I'll just attempt to remove the legs. But yeah, once you have leakage like this, it is very hard to bust through that. It seems to raise the melting point of the solder as it sort of mixes together. So yeah, it is always very frustrating to have leaky components. Now I'm just trying to see what this little capacitor here is. Looks like it says 16, so it might be 16 picofarads. I suppose the schematic should tell me it is C70. Right, according to the schematic, C70 is different depending on if it's NTSC or PAL. So the PAL one should be 15 picofarads, NTSC should be 16 picofarads. So I'll remember to replace that with a 15 picofarad. So that at least gave us a little bit more room to see what's going on. And yeah, I'm pretty much going to remove this guy, these couple of capacitors and resistors around here, probably the crystal as well, and just clean everything up properly. Yeah. The solder on the top side does not want to budge. So that's making things a little bit tricky. We're going to have to use some hot air, I think. Alright, so there's our IC out. You can't even really read the top of it, but yeah, the pins definitely look pretty crusty, as does the board here. So let's remove that Kapton tape. Ooh, and I did melt this guy a tiny little bit. I can always replace it if need be. But yeah, at least we can sort of clean up the board now and get rid of all this corrosion. I'll throw some vinegar on just to neutralize everything. But yeah, I'll clean out these solder holes as well. Yeah, look at the green all over the leg of this little variable resistor. That should be replaced either way. Nasty cap juice. Not cool. I'm kind of surprised that there were leaky caps in here. Like, I used to make it a rule to recap like pretty much everything I came across, and lately I've been trying to do that less and less, but especially with seeing something like this, maybe recapping certain things is still the best way to go. But certainly not just recap everything for the sake of putting new caps in. But yeah, very surprised that the Commodore 64 here had two leaky caps. I guess everything being packed under this VIC-2 can makes everything extremely hot in here. And I guess these caps just didn't survive. And they are in the 85 degree, I don't know if the camera's going to focus. Oh, there you go, a little bit. 85 degree Matsushita or Panasonic or whatever you want to call them. So yeah, definitely 105 degrees should be installed in there, I think. So I'm fighting off most of this corrosion, but yeah, there are still a few spots where the solder just doesn't want to budge, mainly on where those two electrolytic capacitors were and the very close surrounding areas. But I'll get there. Alright, so for the most part things are looking a lot better. Obviously this these through holes where this capacitor was and this one up here still look terrible, and so do a couple of vias around that area, so I'll continue on with them, but yeah, everything else seems to have cleaned up okay. I just need to check some of these traces, like this one along here and this one coming along from the bottom of where that capacitor was. Those two are a bit of a worry. But everything else should clean up okay, and then we'll test out obviously this logic IC. If I've got one on hand, I'll just replace it as a matter of course, but if not, we'll see if this one actually works either way. Alright, so I've revealed the traces that I was worried about, just pretty much the ones where the solder mask over the top of them had turned black, and most of them look okay. I think this one going to the crystal probably looks the worst, but I mean, we tested it before and it was still intact, so it seems to have survived, but I mean, it could have, you know, a fairly low amount of current that it can handle, so it could only just be holding on. So either way, I'm going to retin all these traces and apply some fresh solder mask over them just to stop them potentially corroding any further. Right, so I've just popped on some mechanic UV curing solder mask. So let's see how that pans out. I guess we need some UV light. No idea what the curing time is. Hopefully it's not like 10 years. Of course, it doesn't tell me anything on the tube, I don't think. I might just sort of set this up somehow, just so I can leave it and walk away. Alright, so the solder mask finally cured. It's not the best stuff in the world, so if anyone knows a better solder mask that cures a bit faster than this focus mechanic stuff, yeah, let me know in the comments below. Anyway, I cleaned everything up, put some solder back in the vias just so I don't get them confused with the through hole areas, and yeah, everything looks pretty good. And off camera I quickly tested all the components that came out, so yeah, these capacitors were fine, but they're just little ceramic jobbies, so they're easy enough to replace. And the two electrolytics, which are supposed to be 10 microfarad, were at about 4.5, 4 microfarad. And of course this variable resistor, which looks pretty gunky, is going to be replaced as well. So the only thing I don't have on hand is the 74 LS629. So yeah, I don't know if this one actually works, but I did just clean up its legs, so we'll reinstall that. Obviously I'll put a socket in just in case it needs to come back out. But yeah, even with the Mini Pro, it can't test it because it's not just a standard logic chip. It's a, what is it called? It is called a voltage controlled oscillator. So yeah, that's why it handles the clock signal, I guess. So yeah, can't test that in a Mini Pro. So we're just going to hope that this one still works. But let's reinstall all these components and find out. Alright, that should be everything reinstalled. The only thing I had to substitute was the horizontal trim pot for a vertical one, so it just sort of points out towards me rather than upright towards the camera. But apart from that, yeah, everything looks a hell of a lot better. So let's give it another test. Fingers crossed we get something, anything. A black screen, I'll be happy. Here we go. I got the same pop from the SID chip and nothing. Now, the trim pot here actually adjusts the frequency of the crystal. It doesn't have to be exact in order for us to get a booting computer, but yeah, I'll adjust that once this thing is up and running, but that shouldn't cause an issue and stop the computer from booting. So there is something else going on. Surely it's going to be this, or the crystal. Let's see if I can steal one from another machine. Well, seeing as I don't have a spare 17.73 megahertz crystal on hand, I'm just going to steal one out of my good machine here. That's the first thing I want to try, because it's the easiest thing to remove. If that doesn't work, then I'll pull the 629 out of this machine and put a socket in here too. Right, I've just plonked a known good crystal in there. Let's see what happens. I get the audio pop and no video signal. Let's just check on the scope. I won't bother lugging it over here. There's nothing on the scope. No clock. No, nothing. No. So almost certainly it's this guy. And I'm sure if I put the crystal from the other machine in this one, this will still work. Let's test that theory. Yep, that works just fine. Oh, and I've got Jaffe DOS on it. So, let's pop out this 629 out of this machine, stick it in the other one, or vice versa. All this work just to find out that something else is going to be dead. Alright, so the chip is out, the socket is in. Let's put in the what was working previously chip. Make sure it still works. Yep, cool. Jaffe DOS working, awesome, good. Pop this out, put the one from the other board in here. If this thing actually works, I might cry. Yes, it doesn't work. Never been so happy to see something not working. All right, so before I get these confused, that's a flux pen. Let's put an X. All right, sweet. Now, does our known good 629 bring this machine back to life? Place your bets. No. No, it does not. What? Alright, so we still get no signal, but do we have a clock? Let me bring this here. Let me bring you. Let's zoom out a bit. We do not have a video signal coming out, but we do have a clock signal. So, thank God for that. We are seeing 17.743 megahertz, exactly what we want to see. And let's have a look at the VIC. It's a bit noisy, but God, bring that down a bit. We have our 17.73 megahertz at the VIC and 7.88, which is our color clock, I believe. That seems a bit high for a color clock. Anyway, we have our clock signal at the VIC2, which we did not have before. Why we're not getting a video output, I don't know, but it could be down to those bodge wires on the back, because usually even if the VIC2 is not fully working, you'll still get a black screen, and pretty much that goes for the rest of the board as well. So if anything over here doesn't work, as long as the VIC works and we're getting a clock signal and it's making it to the video output, we should get a black screen regardless of what's busted over here. Let's just do a quick test, swap this VIC, see if that does anything. Otherwise, I reckon it's those bodge wires on the back. Something suspect going on there. Yes, the VIC2 that was originally in the other board does still work, so at least we don't have a dead VIC2, because that would suck and they're not cheap to replace. Alright, so clock signal still there, that is good. Let's just have a look at the video output from the VIC2, see if it's doing anything. So 20, 19, 18, 17, 16, 15. 15 should be our luma and sync signal. And yes, that is a classic luma and sync video signal. That looks correct. And 14 should be our color signal or our chroma, so that is there as well. So the VIC2 is currently outputting a video signal. If we look at it for long enough, it appears the machine is fully working in terms of CPU and everything. So if I expand this out a little bit, so this is our sync pulse that goes down here. This peaking up right here is the very white line that's on the left side of the screen on the Commodore 64. It's usually taken off by the overscan of the CRT. And just after that peak, it drops a little bit, and that would be our light blue border, and then it drops down. And that is our dark blue border. Then it peaks back up, that's light blue, drops back down, that's black down here. So that's the end, and then it draws another line of video. So it looks like this is working, and every so often I can see that there are these little peaks in the middle here. So that would indicate that there's also text on the screen at the moment, if we could see the screen. So this machine appears to be running, we're just not getting video output from it. Let's have a look at those bodge wires. So the machine should be running right now. Let's just see what's happening at our video output. That just looks like noise. That looks like our color. That's nothing. Huh, and there's our sync and luma. I wonder, is that connected to the wrong pin here? Has somebody stuffed around with the pin out of this thing? Right, so looking at my board, we can see where these traces are supposed to go to. So this first one comes around the top and actually connects to this pin in the middle here. And then the second one goes up to this top pin here. on this board, this one was going to the middle pin, but for some reason this wire, which seems to be connected to 5 volts, I thought it was originally connected to the ground plane, but seems to be connected to 5 volts, is going to that top pin there. No idea why that is, because it should come out of this wire here to that top pin. So I'm definitely going to remove that, because it doesn't make any sense why that would be there, why you would want to have 5 volts on that pin of the video output. And I'm also going to remove this and just redo the connections again. Right, that should be much better. Now I know that the bottom of the RF modulator is sitting just behind where these wires are, and it's a metal can, so I'm just going to make sure that I haven't accidentally shorted anything to the RF modulator itself. 92 ohms between that and ground, and 93 between the other pin and ground, so yeah, they're not shorted through those wires to the bottom of the RF modulator. That would probably be a bad thing if it was. So finally, we should get some kind of video signal out of this machine. Potentially a basic prompt. Here we go. Hey, about friggin' time. Yeah, a lot of drama in this little area here, especially with that corrosion going on everywhere. Obviously that 629 chip was faulty from the get-go, and for whatever reason somebody screwed around with the DIN output connector and connected it up backwards, well, with 5 volts to one of the pins. I don't know, really weird, but yes, it works, at least up to this point. Alright, so we know the machine is booting into BASIC just fine, but after hooking up the diagnostic harness, it seems there are still some issues here. So rather than get into that in this video, I'm going to do that in the next video. I do also have to get a keyboard mount printed up, probably replace this funky LED cable, and I might go through and recap the whole machine. Just because if those caps were bad, I don't really trust any of the others in here. So yeah, we're getting cassette port bad, user port bad, interrupt bad. It's saying the CIAs are bad, which is generally what it says if the cassette or user port or serial port doesn't work. But it's also saying U10 bad, which is our 6510 CPU. So that could be related to the interrupts as well, but I just don't know at this stage. So rather than making this video another half an hour longer, let's save that for next time. So as always, a massive thanks to the people that support the channel on Patreon and YouTube memberships. If you want to support the channel, links are down below. And yeah, if you just want to like, subscribe, share the video around, whatever you can do will greatly help the channel. So yeah, as always, thanks for watching, and I will catch you in the next one. Bye. At least the SID works.